Good morning, viewers. This is Kasturi Day. Today, I'm going to start a new chapter according to ICSE syllabus, class 8. So, atomic structure. Okay, this is the last chapter of this of your syllabus. So, I'm starting with today. So, first we come to discuss the atoms, which are known as the building blocks of matter. Okay, so what is an atom? It is the smallest part of matter. Okay, it is the smallest part of matter that cannot be seen through the naked eye. It is so small that you cannot see through a naked eye, but you can see through a powerful electron microscope. If we use an powerful electron microscope, then we can see the atom of an element. Okay, so atoms they are composed of matter, and matter compose elements. Okay, so atoms build up matter, and matter build up elements. In ancient times, the water, earth, fire, air, and sky were considered to be the first 5 elements. Okay, in ancient times, this water, earth, fire, air, and sky were considered to be the first 5 elements. According to Maharishi Kannad, according to his view, matter consisted of indestructible particles, which are known as paramanus, which means param, and anus. So param means ultimate and anu means particle. So ultimate particles. Okay, so according to Maharishi Kannad, he told that matter is built up of indestructible particles. The particles which build up matter, they were indestructible. You cannot destroy these particles. Okay, which are known as paramanus, in which param, there are 2 words in paramanus, param and anus. Param means ultimate and anus mean particles. Okay, and now this particle is known as atoms. Okay, now it's called atoms. Now a paramanu does not exist in the free state. It combines with other paramanus to form a bigger particle called the anu. So the paramanu, which according to Maharishi, the paramanu does not exist in the free state. Okay, it has to combine with other paramanus to form a bigger particle known as anu. Okay, that is atom, which we call it now. Now, according to Democritus, he was a Greek philosopher. He told that paramanus are atoms. Which comes from the Greek word atomos. He named paramanu as atom, and this atom he named from a Greek word known as atomos, which means indivisible. Okay, the atom means atomos, or you can say it is indivisible. Okay, so according to this one Democritus, that this matter consisted of indivisible particles known as atoms. Okay, next is Dalton's atomic theory. Okay, in 1808, John Dalton, he described the atom as the particle which exhibited all the properties of the particular element. Okay, he told that atoms are the particles, okay, that exhibited all the particles of the particular element. Okay, it is the smallest particle. Okay, atom was the smallest particle and it exhibited all the properties of the particular element. The main features of this of his theory was that matter consisted of very small indivisible particles which are known as atoms. Atoms can neither be created nor be destroyed. Atoms of an element are identical in all respects, that is in size, mass, density, chemical properties. Only they differed in they differ in the atoms of the other elements. That is, one atom differs, often one element differs from the other atom of the other element. Okay, now atoms of an element combine in small numbers to form molecules of that element. Atoms of an element combine with the atoms of another element in a simple whole number ratio to form the molecules of a compound. Atom are the smallest unit of matter and that can take part in the chemical reaction where only rearrangement of atoms takes place. So what did John Dalton tell? That atom is the smallest particle and that has all the properties of a particular element. Atom of a particular element that has all the properties of a particular element. Okay. The main features of his theory is that matter consisted of very small and indivisible particles known as atoms that they can neither be created nor be destroyed. It exists. That is the thing. And they are identical in all respect, except they differ from one atom to another of different elements. Okay. Then atoms of one element combine with another atom of the same element to form a molecule of that element. Okay. And atoms of an element, and but in small numbers also. Okay. Like one atom combines with one atom of one atom of the same element. That is, two atoms are combining or three atoms are combining. That is, in small numbers, they're combining to form one molecule. Then atoms of an element, they also combine with another atom of another element to form a simple whole number ratio to form a molecule of a compound. Another, it is the smallest unit of matter that can take part in the chemical reactions where only the rearrangement of the atoms takes place. Okay, the atoms are rearranged in the chemical reaction. Now note, according to the latest research works, most of the features of Dalton's atomic theory are incorrect. Okay, only the feature of atoms that they take part in the chemical reaction, that is correct. The other features of this theory is proved to be incorrect. Okay, so we'll study later what is the correct version of the atomic theory. Okay. Next is subatomic particles of atoms and early models of matter. So according to the latest studies and discoveries in the late 19th and the early 20th century, the atoms are divisible. So Dalton told that atoms are indivisible. The smallest particle, it is indivisible. But according to the latest studies and discoveries, it is proved that in the 19th and the early 20th century, it has been proved that they are composed of still smaller particles. That is, they are still divisible. The three main and these divisible particles, the subatomic particles. Okay, there are three main subatomic particles at present. Okay, so they are electrons, protons, and neutrons. And these particles are also called fundamental particles or subatomic particles. Now, the presence of these particles was proved by the fact that an atom is electrically neutral. Okay, so these particles, when this was discovered, these particles were discovered, that proved that the atom is electrically neutral. Okay, that is, it has both positive and negative charge in equal amount. Okay, but it can gain a positive or a negative charge. Okay, it is electrically neutral, but it can gain a positive or a negative charge. That is, an atom must contain tiny particles which has the positive or negative charge. Okay. Now, these opposite charges balance each other under ordinary conditions to make an atom electrically neutral. That is the thing what I told you, that it has three subatomic particles. I told you three main particles are known as electrons, protons, and neutrons. And these particles are known as fundamentals of subatomic particles. After proving that that is atom is divisible and it has some subatomic particles, it has been concluded that the atom is electrically neutral. That is, it has some particles which has some positive charge as well as some particles which has negative charge, because it can gain a positive charge also and it can gain a negative charge also. So it has some charge, some particles which has charge on them, but they have opposite. These charges are opposite to each other. That's why it becomes electrically neutral. See, the particles here, you can see that they have some negative charge as well as some positive charge. Okay, so it has been later proved that electron, it has negative charge, and proton, which stays in the nucleus, that is has positive charge, but the neutron, okay, that is neutral in charge. Okay, next we come to electrons. Okay, now this has been discovered in 1897 by J.J. Thomson, when he studied the properties of cathode rays. Earlier, William Crookes, British scientist, had performed an electric discharge through gases. Okay, so electrons was first discovered in 1897 by J.J. Thomson when he was studying the properties of cathode rays. But this electrons has been also been found by this William Crookes. He was a British scientist, and he performed some electric discharge through gases. When he was performing some electric discharge through the gases, he also found this kind of negative charge, some substance which has negative charge. Okay, so then according to him, when an electric current of high voltage was passed through a discharge tube. Okay, when electric current was passed, of high voltage, an electric current of high voltage was passing through a discharge tube which contains a gas at a very low pressure. This was proved by William Crookes. Okay, according to him, when he was passing an electric current with a high voltage through a discharge tube which contains gas. Okay, which is a very low pressure, that is 0.01 millimeter of mercury pressure. The rays which emitted through it emitted from the negative terminal. Okay, after passing this electric charge, it showed that some rays were emitting through the negative terminal. Okay, he found that some rays were emitted through the negative terminal. Okay, these he named as cathode rays. Okay, negative terminal was known as cathode and the positive terminal were known as anode. Okay, so this is the discharge tube in which there's a low pressure gas present, air which is under low pressure of 0.01 millimeter of mercury. And he found when he passed through an electric current through this, say an electric current is passing through this. This is the negative terminal, that is the cathode, and the positive terminal, this is the anode. Okay. And when this electric current was passing through it, he found that the cathode emitted certain rays. Okay. And these he named as cathode rays. Okay. Next is electrons again. According to J.J. Thomson, to the studies of on the characteristics of the constituents of the cathode rays, he found that the cathode rays consist of negatively charged particles. He found that this William Crookes, he found that certain rays were emitted from the cathode. Okay, and J.J. Thomson too found that when these cathode rays emitted, they contain some negatively charged particles, which he named as electrons, which is present in the atoms of all the elements. According to his experiment, an electric field was applied in the path of the cathode rays in the discharge tube. Okay, cathode rays in the discharge tube, an electric field was applied, and this shows that the cathode rays were negatively, and these cathode rays were deflected towards the positive plate of the electric field. Okay, see, there's a negative pole and also a positive pole there. The cathode rays which emitted the cathode which emitted these rays, that is cathode rays, that contained some negatively charged particles, because these particles were attracted towards the positive pole of the electric field. Okay, this shows that they contain some negatively charged particles. And when a magnetic field was applied in the path of the cathode rays, they were again deflected in the direction of which moving negative charge would be deflected. Okay, when this was done by electric field, then again he tried with some magnetic field. Okay, when magnetic field is applied, then also he found that these rays, they move to the direction in which the negative charge should move. Negative charge should move. This proved that the cathode rays contain negatively charged particles, which he named as electrons. Okay. Now we come to some properties of electrons. So electrons are the integral part of the atoms. Okay, its properties are independent of the nature. It's an important part of the atom. Okay, and it is independent of the nature of the gas in the discharge tube. Whatever may be the gas present in the discharge tube, that does not is not bothered these the cathode rays which are coming out, the electrons which are coming out from this cathode terminal is not at all bothered according on the nature of the gas. Okay, then electron has a definite mass. It carries a definite electric charge. It has a definite mass. It has an definite electric charge. It does not depend on the nature of the gas which is present in the discharge tube. Then they are integral part of the atoms, and the mass of the electron has been found to be 1/1837 of the mass of hydrogen atom. Okay, hydrogen atom's mass is 9.108 into 10 to the power minus 28 grams. And the mass of electron is found to be 1/1837 into this one, 9.1108 into 10 to the power minus 28 grams. Now, its charge is 1 unit negative charge, that is 1.607 into 10 to the power minus 19 coulombs. Charge's unit is coulomb. Okay, so note, an electron is denoted by the symbol E, small e, to the power 0 and to the base -1. Okay, the subscript, the superscript 0 represents its mass, that is negligible mass. Okay, 0 is negligible mass. It's less than 0 rather, and it's very negligible mass, and the subscript -1 represents its 1 unit negative charge, negative electric charge. Okay, so this portion is electrons. Okay, so I'll stop here. I'll continue with the rest of the chapter in my next video. Please go through this. If you have any doubt, please do let me know. Please write in the comment box, or you can also refer to my email ID, that is kasturi74@gmail.com. Okay. And if you are liking the video, press the like button. Do share with your friends and colleagues so that they can also be benefited from these videos. And do subscribe to get the notification of my next video. Thank you. Thank you for watching, and have a good day.